welcome everyone to the first Confidential Computing Summit. So this is the place for everything about confidential computing. It's so lovely to see so many of you here. In fact, we received double the registrations of what we had expected. And not just the number, but the quality is incredible. We have here the leaders in the confidential computing space from the technology side. We have here use cases and users doing all kinds of transformative use cases using confidential computing. We have here solution providers at all levels of the stack and top academics. Right. So by confidential computing, what I mean is computation inside enclaves. And we use that in order to protect our confidential data. So let's begin this conference by making sure that we all understand what confidential computing is and what enclaves are. Confidential computing, a guardian brave, shields our secrets within the enclave's cave. Attackers lurk outside. In the shadows they conspire, but the castle's gates hold firm, defying their desire. When the data departs, it wears a guise. Something happened to the slides. That's really unexpected. But anyways, when the attackers, they can denial of service attack us, but they cannot get our secrets. So when the data departs, it wears a disguise, an encryption dress of endless ties. Outside the enclave, no secrets are bare. Only encrypted bits float in the air. When data returns to the fortress at last, the decryption key is swiftly cast. Outside the unveiling the secrets rapid and real, in the enclave's depth where none can steal. Because enclaves compute on plain text in the clear, enclaves are fast, have no fear. All right, so because the slides they went a bit off rail, I actually had to recite the second part from heart. And that wasn't very pleasant. So let me go back to where things were supposed to be. So yes, sorry about that. I think we were two people trying to fix the situation at the same time, so it was a race condition. All right, so yes, thank you ChatGPT-4 for this poem. It took 30 prompts and some manual handholding, but you did a great job, and I'll come back to you later. All right, so now that we talked about what confidential computing is, let's talk about what it is not. And I find that a lot of time users are confused between the various mechanisms that are out there for privacy-preserving technologies. How do enclaves and confidential computing compare to them? So first, let me explain at a high level how confidential computing compares to data masking, tokenization, and anonymization. So let me take two tables as examples. So the first table has usernames, and the second table also has usernames, but they are in a different format. And a very common use case is to try to do entity resolution to basically put together these two tables and find a match. So if we mask the data, we basically replace it with, black box and X is X's. And the problem is that like this, you cannot actually do the match. It does hide the data content, but you cannot do the match. So that's not going to be good. Now, another technology that people try is they try to tokenize the data, perhaps using a hash, and try to anonymize it. So the idea is that they hash the whole name, and then if you hash two things that are equal, and the hash is going to match. So the problem, though, is that if you have any small difference between these names, then the hashes are not going to match. And moreover, hashes don't really give you security and privacy because you can always try to reverse them by trying different names, see which one it matches. Okay? So basically, in a nutshell, data masking, tokenization, and anonymization doesn't let you compute on the confidential data. It makes you choose for any specific situation. Do you want the functionality? Do you want the computation? Well, then reveal your data. Or do you want the privacy? Then you don't have the computation. Okay? So the question is, can we have our cake and eat it too? And the answer is yes, with confidential computing. That's what it's designed for. It's designed to have the data encrypted and still and confidential and protected and still be able to compute on it. The other technology that people tend to be confused about is differential privacy versus confidential computing. So in differential privacy, what happens is that you actually don't have the data protected during the computation. The data is in the clear, in the cloud. And in the cloud or the servers, you can compute some queries that the user or data analyst sends you. And the only difference is that when you return the result, you actually add some noise to the result to make sure that the result itself doesn't reveal to the data analyst any information about the specific user in the data that the result was computed on. But again, during the computation, the data is encrypted. It's not encrypted, it's revealed, it's available. Okay, so attackers can get in and get it. And the only thing that differential privacy does is add some noise to the response. Now, this also means that differential privacy goes very well with confidential computing. They're complementary. You can, for example, protect your data during computation with confidential computing, and before you output the result from the enclave, you add a noise to it with differential privacy. All right, and the last category that people ask me a lot about is homomorphic encryption and secure multi-party computation. So here, you actually can compute on the encrypted data, and you can do this with some very beautiful mathematics that even I'm doing research on. But the problem is that it's still very, very, very slow. So if you want to run rich data analytics or you want to train neural networks, it's going to be orders of magnitude slower than regular computation and than confidential computation. Okay? So the nice advantage of confidential computing is that on the one hand, it gives you this abstraction that you're computing on encrypted data. Why? Because the attacker outside of the enclave, outside of the silicon that forms the enclave and the die, can only see encrypted data. Encrypted data comes out, encrypted data goes in, encrypted data in memory. So from the perspective of the attacker, it seems that the enclave is computing on encrypted data. Now, at the same time, the advantage of this technology is that it actually decrypts the data in the CPU, deep down in the hardware, where only the metal can see the data. And because of that, it can compute on regular data at CPU speeds. Okay, so it has the best of both worlds. It's efficient, and it's also, protecting your data with this abstraction of encryption. All right. So because of this power, confidential computing has a bright future and has a lot of different use cases. It can help with all the rising data security risks. It can help with more and more stringent privacy regulations. And it can also help with rapid innovation because security and confidential data can be protected, so you have less concerns. All right, and so the Markets and Markets published a recent report estimating the market for confidential computing to grow to 60 billion by 2028. All right, so there's many applications for confidential computing and enclaves. One of my favorite is providing data privacy in generative AI. So the idea is that you want to be able to use LLMs for productivity, but at the same time, you also want to keep your data private and confidential. So here's some ways in which you can actually protect your PII, financial data, healthcare data, and IP using confidential computing. So one way, the first way is let's try to protect the query. So I'm sure many of you heard about, in the news about all the concern around LLM providers seeing your queries. For example, Samsung employees uploaded proprietary code to ChatGPT, and Samsung actually blocked ChatGPT inside the company as a result. So to protect these queries, what we can do is we can have the LLM provider keep the LLM model in an enclave. So it's trained outside, but then it's put in an enclave, and the users can send encrypted query to this LLM model in the enclave, In the enclave, the queries get decrypted. So again, only the hardware gets to see the queries. The inference happens and the result is produced and it's encrypted and sent outside of the enclave. Okay? So the point is that the LLM provider doesn't get to see the queries or the results, but it can still provide you this LLM service, which is very powerful. Another way you can use confidential computing for LLMs is to actually train your model on confidential data. So let's say that we have a data provider that has very confidential data, is willing to use it for some training, for the creating of some model, but doesn't actually want to reveal the data. So basically what you can do is the data provider can send encrypted data to the enclave, and inside the enclave you can train the model. So again, the LLM provider is not going to see the model. And you can also use this in the cases where you want to protect queries and want to do retraining. And another interesting use case is when you actually want to do this prediction on-prem of the client and you want to have the model on-prem of the client. Many times clients say, look, LLM provider, I cannot send you queries and proprietary information outside of the prem. I have to stay on-prem because of regulations or privacy concerns. So in that case, what can happen is that the LLM provider can send the model to an enclave inside the premise of the user, and the user can send queries and get back responses, but without actually seeing the model. Okay, so this is another very powerful use case. All right, so let me wrap up my talk by mentioning a few statistics. So we had 12 companies that are premier sponsors, and that's wonderful. Thank you so much. The conference has been oversubscribed. We have, as of today, roughly 250 registrants when we were planning for 150, which is awesome. We also have 55 keynote talks, track, panels, and CFP speakers. So that's a lot of density of really high quality information within a day. And we know it's going to be hard to absorb, so we are going to record those talks and put them up for later consumption. And also next year, we plan on having 2 days for the summit so that you have more time to network and learn. This was the very first event, so high energy first day. Also, in terms of speaker submissions, we got much more than what we expected. We arrived at 90 submissions for an initial of 6 slots. So we ended up increasing those number of slots as well to accommodate, roughly 12 CFP. Okay. And I want to really give a big thank you to all of our sponsors and speakers who are making this summit possible. And thank you to the CCC for being a co-organizer with us. A very brief announcement in keeping with the times. At the end of the day, we're actually going to have an LLM privacy and security generative AI panel. So that's going to be in this room at 5:20 p.m. All right. So please enjoy this conference, network. That's why it's in person. Meet people and learn. If you don't know how to get started, then go to the espresso bar or go to the LED panel and create your patterns and maybe, teamwork with somebody. And this day is going to wrap up at 5:45 p.m. All the sessions will be done by then. And we will be in the next room having food, cocktails, and fun next door. Thank you.